Okay, I'm going to try this one in a darker room so you can see the board a little better and my face a little less. I think that'll probably be better for us. Okay. Today we're going to do parametric equations that form lines, and I have two of them, x equals 5t plus 3 and y equals 3t. And I want to know what is the slope of the line that contains those parametric equations. We're going to do the same thing. We're going to start off by solving for t. So on the left-hand side, we'll get x minus 3 is equal to 5t, which tells me t is equal to x minus 3 over 5. Going to plug that into the equation for y. Y is equal to 3 times x minus 3 over 5, which is going to be 3 fifths x minus 9 fifths. The slope of the line is going to be 3 fifths. The slope of the line is going to be 3 fifths. The coefficient of the linear term in y divided by the coefficient of the linear term in x. Let's just double check that to make sure. Suppose I have the two parametric equations, x is equal to at plus h, and y is equal to bt plus k. And I want to know the slope of the line that comes from those two parametric equations. All right, let's go ahead and solve. X minus h over a is equal to t. So when I plug that over here, y is equal to b times x minus h over a plus k, which is equal to bx over a minus bh over a plus k. All of this is a constant term, which will give us our y value of our y-intercept. Here I've got b over ax, meaning the slope of the line is b over a. The slope of the line is the linear coefficient of the y divided by the linear coefficient of the x. We're going to use that now to determine a parametric equation for a line segment. If you do not like stray marks on the board, just pretend like they don't exist. I don't know if I can catch all of them. All right, so let's say I've got a line segment. The initial point of the line segment is 2, 0, and the terminal point for the line segment is negative 3, 8. Okay. First thing we know, we can figure out the slope of the line that contains these 2 points by doing y2 minus y1 over x2 minus x1. The slope of this line is going to be 8 minus 0 over negative 3 minus 2. So the slope of the line is going to be 8 over negative 5. All right. So we can use it now. If that's the case, and you remember how we did the parametrics to find the slope, when I'm writing the parametric equations that are going to give me this segment, I'm going to have x is equal to some sort of negative 5t, and y is equal to some sort of 8t. Let's see if we can figure out what to do from there. Well, we know our initial point is 2, 0, and so when t is 0, I want my x value to be 2. Well, plugging in a 0 gives me 0, so I'll put a plus 2. And I want my y value to be 0. Well, there you go. If you plug in 0 for t, y is equal to 0. So this will give me my initial point. Now, what does my t value have to be? Where do I stop in order to get a terminal value of negative 3, 8? Well, let's do this. Let's go ahead and plug in and see what we get. So I'm going to need my x value to be 8, so negative 5t plus 2, I'm sorry, my x value being negative 3 is equal to negative 3. Negative 5t equals negative 5. T is equal to 1. In case you're wondering, let's see what happens with the y. I need my y value to be 8, so 8t is equal to 8. Sure enough, t is equal to 1. So my parametric equation that gives me a line segment whose initial value is 2, 0 and whose terminal value is negative 3, 8 is going to be x is equal to negative 5t plus 2, y is equal to 8t, where 0 is less than or equal to t is less than or equal to 1. This isn't the only parametric equation that will give you this line segment, but it seems to be the easiest way to do it.